Good afternoon, guys. This is Professor David J. De Los Reyes, an electrical engineer by profession, had been a professor of electrical engineering, and had been a department head of our school in our electrical engineering department. I am also an electronic troubleshooting on the hands-on topic. I could do hands-on troubleshooting, okay, up to the component level. Okay, let's proceed. The topic for this afternoon will be a variable separable first order differential equation. Okay, let's proceed. My topic for this afternoon, guys, under my channel, I am now on the course differential equation. I have already finished differential calculus and integral calculus, and this is now my third complete course that I will be vlogging, okay? And we are now on topic number 3. Okay, let's proceed. We are now on lesson DE03, differential equation 03. The title of the topic is differential equation. Subtopic is first order differential equation, first order DE differential equation. And the main topic for this afternoon, because there are many classifications of first order differential equation, and the first one is actually variable separable. So this afternoon I will be presenting another problem on the variable separable. So the main topic for this afternoon is variable separable number 2. The last time around, it was number 1. It was another problem. So I will be presenting different problems under variable separable. Maybe I will give you 5 variable separable problems, okay? Then we will proceed with the next topic on the so-called first order differential equation. Okay, let's proceed. I will try to read the problem. The problem is evaluate the value dy dx equal to x e to the negative x with the given initial condition x equal to 0 when y equal to 0. We are given the initial conditions, so it's a must for us to compute for the constant of integration. So to bring out the particular solution of this one, we must have to solve for the constant of integration. So meaning, the problem is asking for the particular solution. And the topic is under variable separable. Okay, let's proceed with the solution. Solution. Okay, it's a systematic solution, guys. We write vertically downward, then left to right. Write as legibly as you can. So when you are taking the board exams, that will be good for you. The examiner will not be bored checking your papers. Okay, let's proceed. dy dx equal to x e to the negative x. This is under variable separable. So if we try to multiply all the terms by dx, this cancels. What remains on the left will be dy. Right hand side will be x e to the negative x times dx. So after the multiplication of dx for all the terms, we separate the variables. Okay, that's why the topic is variable separable. It's always separable since the topic for this afternoon is variable separable. Okay, to solve for y as a function of x for a particular solution, we must have to integrate. So the integral of dy equal to the integral of x e to the negative x dx. Okay? Or I will repeat on this line here, the integral of dy equal to the integral of x e to the negative x dx. There's a differential on the left hand side, there's a differential on the right hand side. So we are actually given a differential equation, because the definition of a differential equation is that it should contain differentials or derivatives. That's why our first topic under differential equation I emphasize on the concepts that the definition of a differential equation is that it should contain differentials or derivatives. If we try to look at the right-hand side, that will be a problem of integration already. We are done with integral calculus, okay? From the basic, the differential of x to the complicated thing. So it's up to you to bring out the correct solution in this one. Okay? Oh, let's proceed. The integral of the right-hand side, it seems this should not fall under the power formula. Because if you think that this is under the power formula, okay, the differential of the exponent should be just be simply negative dx. But we got an x over here, so it does not fall under the power formula. And I think the proper solution is this one, is so-called by using integration by parts. The integral of u dv, one of the integration processes under integral calculus is the integration by parts. That is the integral of the form u dv is equal to ub minus the integral of b du. As a trial, we will let u equal to x, okay? You could change later on if you cannot solve the problem, but for the meantime, let's let u equal to x. So if u is equal to x, du will be dx. And if u is x, what remains should be db, right? Because it is of the form the integral of u db. So I will place it here, db equal to e to the negative x dx. Okay? I am just segregating the value of u db. Integrating both sides, the integral of db equal to the integral of e to the negative x dx. This is integrable, okay? Left-hand side, it is now integrable, but we must have to verify the value of u, the complete differential. The value of the exponent is negative x, okay, negative x. So du will be negative dx. It is not exact. We are lacking the negative sign on this one. Okay, there should be a negative sign. So we will place a negative here. Then we will place negative 1 outside to integrate the right hand side. Therefore, b now will be equal to, after placing the negative 1 outside, it now falls under the integral of e to the u. And it will just be simply e to the u times du. So it will be b equal to negative, okay, e to the negative x. I bracketed this one with the red thing because later on I will be going back to the values of u and b on the substitution. So easily seen because I mark it with a rectangle bracket. So the integral of dy now, we will go back this here now, equal to the integral of x e to the negative x dx, right? Okay, I will start again. I say the solution should be integration by parts, so this should be ub minus the integral of b du. Okay? I will place the value u. What is u? U is this. Okay? And what is the value of b? It is this. So I just took the product of x times negative e to the negative x minus the integral. Or what is b? B is actually negative e to the negative x. Okay? And what is du? Du is dx. Okay? So this is the times dx. Okay? I will rewrite this one. Okay? The second part is now integrable, but we must have to verify the value of the differential of the exponent. The exponent is actually negative x, and du is negative dx. It is not exact, right? So I will place a negative 1 inside, then I will place a negative 1 outside. Okay? After placing the negative sign inside and the negative sign before the integral, it now falls under the integral of e to the u du. Okay? So this should be negative x e to the negative x. This is minus, it will now become plus. Okay. Sorry for this one. So they should be, but this got a negative sign, guys. Okay, negative plus negative e to the negative x plus c. So what will come out? This should be minus minus. This should be minus. I factor out, and this should be plus. Okay, sorry for that one. This should be negative, this negative, because plus and minus will be negative. I factor out the common factor e to the negative x, but this is supposed to be preceded by a negative sign, 1 plus x. Okay, plus c. So that this should be plus, guys. So that's the general solution. Okay, and solving for c, we are given the initial condition. When x is 0, y is 0. So y will be equal to, I will just place a plus sign here over guys. Plus. And this should be minus. Okay? There's a negative here, but the one inside will be plus. So this should be negative. 0 will be equal to negative e to the negative 0 times the quantity 1 plus 0. So this should be negative 1. Okay? Because e to the 0, this is actually 1. There is no such thing as negative 0. Negative 0 or 0 will just be equal to 1. So this is negative 1 times the quantity. What comes out will be, sorry for this one. This is 1 plus 0 plus c. There's a negative 1 over here. So c now, this negative, we place it back on the left hand side. So this should be plus 1. The value of c should be plus 1. Sorry for that one. And for the particular solution now, we'll go back to this. We will substitute the computed value of c. So this is now negative. So for this one, guys, this is plus. Y now will be negative e to the negative x since the quantity 1 plus x minus 1. This is minus 1. The value of c is minus 1. Oh, is it minus 1? Oh, plus 1. Okay. The final answer will be y. E to the negative x should be preceded by the negative sign. We are just following this. Times the quantity 1 plus x plus c. But the value of c is plus 1. So this is plus 1. Particular solution. As simple as that one. So actually, the under variable separable, the main problem is actually the integration process. If you do not know how to integrate after separating the variables, that's your problem. But to solve the problem, it's a must that you should integrate by any means necessary that is applicable to the given problem. Okay, good afternoon, Los Angeles.